This is a brief introduction to the chapter of carboxylic acids and derivatives. The first reaction that can help us prepare a carboxylic acid is the oxidation of primary alcohol or the oxidation of aldehydes. For example, 1-butanol can be oxidized to butanoic acid by use of the Jones reagent. Another method for the preparation of carboxylic acid is the oxidative cleavage of alkenes. The condition is to have vinylic hydrogen, so you can split the molecule into two halves, in this case the production of a ketone and a carboxylic acid. When alkyl benzenes are heated in the presence of strong acids, if the alkyl substituent has benzylic hydrogens, the product of this oxidation is benzoic acid. We have seen the Grignard reagent as a useful method for the synthesis of alcohols, but when we react a Grignard with a carbon dioxide molecule, the product is a carboxylic acid. Hydrolysis of nitriles can give us two different products. We can get an amide or we can get a carboxylic acid. Some of the reactions that we will explore in this class are the reduction of carboxylic acid to produce a primary alcohol, the acid-base property of carboxylic acids, which means that it can react with strong bases or with weak bases, and then the nucleophilic azole substitution. We have a full chapter just about that, and we will see the mechanism how we can add a nucleophile, explore the incoming nucleophile, and what will be the leaving group to produce a brand new carbonyl compound. And then we also have a brand new chapter about the acidity of the alpha carbon that is not only limited to the family of carboxylic acids, but it will be also part of the family of esters, ketones, aldehydes, etc. Let's explore the reduction of the carboxylic acid. We can use two different reducing agents. We can use lithium aluminum hydride, which is a strong reducing agent, or we can use borane, which is a much more selective chemical. In this example, we can see that the carboxylic acid group is being reduced to a primary alcohol while keeping intact the nitro group. When we use lithium aluminum hydride for the same reaction, then we are reducing both the carboxylic acid group to a primary alcohol and the nitro group to an amino group. Here we list the derivatives of carboxylic acids. We see first the azole halide, when instead of an OH we have a halogen, the acid anhydride, an ester, a thioester, and three different kinds of amides, a primary amide, secondary amide, and a tertiary amide. Carbonyl compounds are separated into family A aldehydes and ketones that will undergo addition reactions, and family B, the family of carboxylic acids and derivatives that will undergo nucleophilic substitution. In a family A, we will add a nucleophile, producing a tetrahedral that will be collapsing after the addition of a very weak acid. If we explore the rationale for that, when we see the hydrogen 2 electrons hydride is a very poor leaving group. Methane pKa is 60. It is a very weak acid. Therefore, the carbon ion and the hydride ion are both poor leaving groups. The starting point of the addition of a nucleophile to an carboxylic acid derivative is similar to that of aldehydes and ketones. You add the nucleophile to the carbonyl, you are going to form a tetrahedral, but the tetrahedral will collapse when the carbonyl is reformed, kicking off the weakest base. Let's review it. We add the nucleophile to the carbonyl, make a tetrahedral intermediate, and then we are going to expel the weakest base. In this case is the Y-. We usually say that this is the family of carboxylic acids and derivatives because we can say that substances can be prepared from carboxylic acids, But the reality is that carboxylic acid is very unreactive. The carboxylic acid group will need to be activated by preparing an acyl halide or an anhydride. Here we look at the order of reactivity of derivatives of carboxylic acids. The most reactive of all is the acyl halide, followed by acid anhydride, thioesters and esters, and the least reactive is the family of amides. Once we get an acyl halide, we can use this substance to prepare other derivatives of carboxylic acids. An ester can be prepared from an acyl halide, but an acyl halide cannot be prepared from an ester. This is because the OR group is a stronger base than the Cl-. In biological systems, carboxylic acids are unreactive too. Those get activated by two different methods. One is the phosphorylation of the carboxylic acid group by the use of molecules of ATP to create a mixed phosphoanhydride bond. The second method is creation of a thioester bond by use of the thiol group of coenzyme A.